Hey everyone, welcome back to the channel. Today we are diving into something really interesting. Janus 1.3b, one of the tiniest yet competent, truly multimodal LLM. What sets this model apart is that despite its smaller size, it delivers powerful results in natural language processing and image generation. This is a perfect example of where AI is heading, smaller models yet versatile and multimodal. For those of you who are new to this channel explores the latest breakthroughs in AI research, especially around LLMs and VLMs. So stick around because Janus is a model you'll want to know about. And I will teach you how to deploy the model for its multimodal abilities and image abilities easily in less than 200 lines of code. So what exactly is Janus 1.3b? At its core, this model is a vision language model designed to handle textual and visual data. With just 1.3 billion parameters, Janus is significantly smaller than some of the other LLMs and multimodals we have discussed earlier on this channel. But don't let its size fool you. It can perform both text and image generation, making it a powerful tool despite its relatively compact size. Unlike most models, which specialize in one area or need large architectures to function effectively in multiple domains, Janus achieves this multimodal functionality at a much smaller scale. This is a massive step in making AI more efficient and accessible, and most importantly, scalable. Let's start with its architecture. The model processes text understanding, multimodal understanding, and visual generation through independent encoding methods that eventually feed into a unified autoregressive transformer. This design allows it to handle different types of input, text, images, or a combination of both in a highly efficient manner. Here's the breakdown of how it all works. Text generation. The model uses the built-in tokenizer from its underlying large language model. This tokenizer converts text into discrete IDs, which are then transformed into feature representations. The LLM processes these features in the same way as any other text-based model. Multimodal understanding. Janus integrates SIGLIP, a powerful vision encoder that extracts high-dimensional semantic features from images for image processing. These features are flattened from a 2D grid into a 1D sequence and passed through an understanding adapter. This adapter maps the input features into the input space of the LLM, ensuring that both image and the text data are represented in a way that the model can understand together. Image generation. Janus employs a vector quantization tokenizer to generate images. This tokenizer converts images into a sequence of discrete IDs. These ID sequences are then flattened out and passed through a generator adapter, which maps them into the LLM's input space. This allows the model to generate images from a prompt. A specialized image prediction head is trained for this task, whereas the model relies on the LLM's existing text prediction head for text-based tasks. Now, let's talk about performance. Despite its relatively small size of 1.3 billion parameters, Janus is competitive across several multimodal tasks. It excels in VQA, benchmarks, COCO captioning, and image text retrieval. The model is designed to handle real-world multimodal applications where parameter efficiency is the key. While large models outperform the model on tasks that require deep reasoning over complex text or high-resolution images, Janus hits the sweet spot by balancing efficiency and performance for general-purpose multimodal applications. Now let us see how you can go about using the model for multimodal inferences. The generate answer function takes an image and a question as inputs. It first loads the VLGPT model, tokenizer, and visual language chat processor. Then a conversation structure is defined, where the question is paired with a placeholder for the image. Next, the image is prepared for processing. The necessary inputs are batched. Based on these prepared inputs, the model generates input embeddings. The VLGPT model then generates an answer by processing these embeddings using a specified attention mask and token identifier for beginning, end, and padding. Finally, the output tokens are decoded into a human-readable format, yielding a response that combines visual context with posed question. Finally, let's examine Janus's image generation capabilities. While it's not as large as dedicated models like DALL-E or Stable Diffusion, the model creates high quality images from textual inputs in an incredibly compact form. As mentioned, the model uses a VQ tokenizer to convert images into discrete tokens. These tokens are then processed using a latent diffusion model, which generates the image in stages, refines it over time to match the text input. The result, images are highly coherent, contextually accurate, and especially when dealing with more straightforward and abstract prompts. Now let us check out how to use this model for image generation. The process starts with tokenizing the prompt using the V1 chat processor. This converts the text into numerical representations that the model can understand. We create initial embeddings from these tokens which are crucial to the model to interpret the input context. The generation happens iteratively, predicting one image token at a time. This is where the classify free guidance technique comes into play. It allows the model to balance between two outputs, one conditioned on the prompt and one unconditional. This mechanism enhances the creativity of the generated images, while ensuring they remain relevant to the original prompt. As the model generates tokens, it prepares the corresponding image embeddings, which are then used to refine the input for the next iteration. After generating all the required tokens, the model decodes them into actual images. The resulting visual outputs are then saved as JPG files in a specified directory. So there you have it. Janus 1.3b, a small but compelling multimodal that punches well above its weight. Its ability to handle text understanding, model reasoning, and image generation in such a compact framework is a testament to the efficiency of its design. If you wish to check out the complete code and implementation, head over to my repository on GitHub, which holds the code for this. Or alternatively, if you would like to read in detail about the model, check out the article which I have linked down below. For those interested in multimodal AI that can be deployed in real-world applications without the need for massive computational power, this model is what you should be looking at. If you enjoyed this breakdown and want to stay updated on the latest VLM and LLM architectures and research, be sure to hit that subscribe button. I'll catch you in the next one. Until then, keep your models fed and your code bug-free.